Hey, hi everyone. Good evening. Good evening, and welcome to the lecture on geometry. Welcome to CAT Ninjas. I warmly welcome all CAT 21 students, especially those who are preparing for CAT 21. Welcome and join me as we discuss circles today. So, in the last four lectures, I guess, on geometry, uh, we were discussing the triangles, and today we'll discuss about the curves, right? So curves is nothing but the circles, because these are the two fundamentals. Once we have a fair control over the triangles and circles, I guess most of it could be done from there. All right, I warmly welcome all of you. So before I start the lecture, let me introduce quickly myself. I'm Belvi Srinivas. I've been working in the test prep industry for the last 14 years, that's since 2007, and I worked in various capacities in different organizations under test prep. And yes, over a period of time, I did develop some good skills to train the students in the area of QA, DI, LR. Yeah, that's briefly about me. And yeah, welcome Isha, welcome Nazia, welcome guys, welcome. Yeah. So here, in case if you're looking for a short interactions, so you can join me on this particular Telegram group. Not only I, there are many active students. They can also you can interface with them, and you can resolve some of your concerns out there, and wherever it is required, I will chip in and try to address some of your concerns. Yeah, that's how we can integrate and work together. That's briefly about me. And before I start the lecture, let me quickly introduce about the courses and the schemes the Unacademy offers. So there are certain courses which are which are launched today, that is 30th November. So one is the weekend batch for CAT 22 students, and there is an NMAT batch for CAT 21 students. Those are appearing for CAT 21, ZAT 21, and IIFT. So there is an NMAT specific batch which is launched today. So if something else of some importance to you, you can take a look at this. And if you are also looking for CAT 22 and a weekday batch, which is just started about a couple of days back, you can take a look at this courses as well. Yeah, so to attend some of these particular courses, you may have to look for the subscription. There is 6 month subscription if you're a CAT 21. Most advised is 6 month subscription, through which you can also attend some structured courses on SNAP, IFT, ZAT, maybe TIS, Solid, and MyCat, that is MyCat. All these, there will be structured courses which would be provided. You can try and take the subscription to attend these particular structured courses. Yeah, so whatever the prices that has been mentioned out here, you will get 10% discount on these listed prices whenever you use an educator code, any educator code, including my code, which is Belvi 100. Yeah. Yeah, and if you're looking at one-to-one interactions, more of one-to-one interactions every now and then, so then iconic subscription is the preferred one. You can have, there are 6 months, 12 months, and even the shorter packages as well. So on all these subscription prices, you get 10% discount whenever you use a subscription plan. Okay, you may think that, okay, how many sittings we get, how many one-to-one interactions can be availed. In usual scenario, in a 6 months iconic plan, you can have 25 one-to-one interactions, but there is an offer extended till tomorrow, 31st. You get 35 one-to-one or 35 one-to-one meetings that you can set up with the mentors of your choice in a 6 months period. If you're going for an annual subscription, you can set up 70 if you buy the package by tomorrow. Otherwise, generally it is about 50. Yeah, what do we do in this? You can discuss your study plans, you can discuss your strategies, you can discuss your test analysis, you can bring forth your Excel sheet, project it. You can look forth already now, look for what are the parameters where you can seek certain suggestions, or it can be your doubts, so whatsoever it could be, right? Or it can be your validation of your application forms, or the B schools that you would like to apply. So profile check, any of this, already any of these can be kind of taken up as a discussion, short discussions in one-to-one capacity. Yeah, that's pretty much about so what we have, and there are few offers going on till 31st. There's another offer with respect to time period. If you buy a 3 month package, you get 1 month. If you buy an annual package, you get 3 months. So there are certain offers which are raining, just like a Diwali offers. We have some offers out here as well. Okay, that brings us to the end of the discussion. So may I quickly know who all are here in the meeting? So that would be nice to co-travel. Yeah, all of you guys can let me know who all have joined this evening. Quickly let me know in the chat. Put that in the chat. Yeah, I can see Isha, Nazia, Kishan, and Keval joining at this point in time. And anybody else out here, quickly let me know who else is out here. Yeah, put something in the chat, guys. Put something in the chat. I hope it's not there is no delay, there is no lag. So quick click on the live and stay live. Okay, Chinmay is here, Rishabh is here. Good evening, good evening, good evening. Yeah, good evening. Anybody else? That's it. Others don't want to disclose your name, something like that. Ah, Kapil is here. Okay. Ah, okay, Keval. All right. Yeah. Maybe that is the time, if you know the announcements, probably that is the time where you can set up your desk as well, right? You log in and set up your desk, keep pen, keep book, right? Yeah. How many of you had dinner, by the way? How many of you generally take dinner and then attend lecture? Yeah. How many of you finish dinner, then attend lecture? Can I quickly know how many of you are done with your dinner? Just to understand. I mean, those who take early dinner, late dinner, how's your cycle like? Okay. Rishabh is done. Keval is done. Okay. Okay. Others take late. Is it after class? Who's this beast? Is this Kushagra? Okay. Okay. Some of you, Rishabh, you do after. Okay, that late. Okay. Ashutosh, what is that? I asked about dinner and what? Okay, yet to have after lecture. Okay, Nazia, you also eat after lecture. Okay, after around 11:30. Amazing. Okay, the kitchen won't be closed at home. Kitchen is still open. Because I remember during my college days or school days especially, the kitchen is closed. My mom used to close the kitchen is closed, right? In the sense, like, not just to inculcate that you should eat early, so they used to close the kitchen by about 9ish. Good that, okay, you have that great flexibility, kitchen is open. Yeah, yeah, I mean, any which ways, all right. No, so I'm not saying that it is right, wrong. Yeah, good that already in some of the homes they keep the kitchen open till midnight, 12 o'clock, kind of, right? That's good. Or you guys make Maggie for yourself and eat. I don't know which way it is. That is something all right. No, even if the kitchen is closed, you can get something on your own. Yeah, that's what Rishabh is saying. I can get it on my own. Okay, cool. All right. So here we go. All right, let's get started. Let's do circles, guys. We were doing triangles for the last 3-4 lectures. Good, good. Yeah. But my suggestion to you guys, so eat little early. That is good. Okay, eat little early. So those who have the late eating habits, turn it to little early eating habits. That is good for health. From the health perspective, it is good. Yeah, nothing wrong. At your age, everything is fine. But then slowly transition has to happen. So in the longevity, considering the longevity, it is good. Certain things are good for body. Certain things may not be as good. Certain practices. At this age, you will not feel it. But yeah, cool. Any which ways, doesn't matter. At this age, doesn't matter. Now don't try to change too many things before the cat. Now do whatever you are doing. After cat, consider all those things. At the moment, let the status quo be maintained. Don't try to do too many changes because there is already enough changes happening in the mind with respect to cat. Now don't try to practice too many new things at this point in time. So let's do circles. I'm hoping that all you guys are sitting with a book, pen, and prepared a little bit. All you guys have read a little bit through because yesterday itself I announced that we are going to do circles. So have you read a little bit about circles? I mean, just refreshed your mind a little bit, half an hour, 1 hour, 2 hours, or no? We're all masters of the subject. We don't need any refreshing. Okay, well, good. Yeah, that is pre-reads. Basically, what I'm saying is pre-reads. Right? Good. Isha has done some pre-reads. Kishan has done pre-reads. Very nice, guys. This is very encouraging. You are actually poised for your case studies. Very good. Kapil has done pre-reads. Umesh has done pre-reads. Neha, good evening. Yeah, okay. Nice. No, get into this habit of pre-reads because, like, once you get onto the top B school, so you have to read at least 3 to 4 case studies on a given day before you go to the lecture because prof is going to take up that particular case study, which will be starts with 7-10 pages and goes up to 15-20 pages. Right? Yeah. So, and then they will not read that case for you. That 7 to 10, 15 pages you should have read, and they will directly start the discussion. And the prof remembers who are all discussing, who doesn't discuss, and based on that, some scoring will be done. All right, now let's be mindful about it. No, I don't read. I have not read any case. I went and sat there. Prof knows about it because you are not able to open your mouth and have a discussion. Classrooms are completely discussion, not like the way I'm discussing. All right, you enter the B schools. How much prof is talking, the batch would be talking so much. Sometimes in a class it happens that out of a 75 minutes Prof would have ended up speaking for 15-20 minutes. The rest of the 50 minutes, the students would have spoken about it. Batch of 60 students would have spoken more than what Prof has spoken. That's a reality, because we learn through those kind of peer interactions. Prof just channelizes, energizes that particular interaction. Not in every class, not in every class. Now in that 50 minutes, if you don't open your mouth and you speak, Prof knows how much of pre-reads have gone there into that particular lecture. Let's be mindful about it. Yeah. So why I'm saying is, a pre-reads is a part of your life hereafter. You go to a meeting in a corporate, you would have prepared and gone. Therefore, there is always a pre-read. There is always a pre-read. Okay, get into that habit here. When I keep saying that, hey, read something and come. Just spend that 1 hour, half an hour, 2 hours, whatever that you want to spend and come. That's important there. All right, guys. Here comes a short question. So warm-up question. Here we go. I hope it's visible. Yeah, warm up yourself with this question. Very simple question. 1 minute question it is. 1 minute question. Quickly warm up and let me know the answer. Yeah, Beast, you can let me know your name. It doesn't make much sense for me to call your name as Beast and Clutch Gaming. Yeah. Put your name there. Let it okay. You don't have to change there. You just let me know your name. Welcome, any which ways. Welcome, Barka. Okay, all right. Let's see this. Okay, the very first question had a construction. That was the problem, right? The problem was the very first question had a construction. Some of you may be thinking, telling that, okay, first question, construction, how sad it is going to be, isn't it? Yeah, okay. So you might have to do this construction in this question. Yeah, because I already set the tone for you, right? Saying that, hey, given lines may not be enough sometimes. Always be open to it. And very first question is not a great idea, but I deliberately did this. Very first question. Yeah, what we do here is, the moment you finish the first 3-4 questions, most of the important concepts would be revised. All right, most of the important concept would be revised. So as I start doing this, I will also give a little bit of background to this. Fair enough. All right. So I said that, hey, this is A, B, A, O, this is 24. I know that this is radius. Man, in the circle, the most important thing is radius. Okay, because there will be many radius, right, in most of the circles. So you can just draw the radius. You will find that there are many radius that you can draw, and they would be equal in length. So therefore capitalize on that particular fact. Okay, so therefore this length is equal to this length. Why? Hey, this is radius. Focus only on this triangle. Don't go beyond this. Focus only on this triangle. Therefore side opposite this radius 24. Therefore angle opposite this this is also 24. Fair enough. So therefore I know that, hey, that measure is 24. Forget this. Now this is over. Now let me focus on this particular triangle. What is given to me? BCO. All right, now BCO is 31. All right, this is 31. Now I know that, hey, this is also radius. Therefore focus only on this triangle. So side opposite this particular radius is 31. Therefore side opposite this, angle opposite this side will also be 31. Okay, so therefore now figure, let's close this particular figure. What do I know? Now I know that, hey, angle here is 31 plus 24, which is nothing but 55. If this is 55, this is called as inscribed angle. This is called as inscribed angle, right? That's the name, inscribed angle. You might have seen these kind of figures. Say that, hey, if there is a chord here, if this particular chord, it inscribes an angle theta here, then the same chord inscribes central angle. Inscribed angle is theta. This is called as inscribed angle. Then if O is the center, this is called central angle. Central angle will be 2 theta, central angle, right? I'm not getting into the proofs, etc., because I told that, hey, have the pre-reads there. Good. So therefore from here nobody has a problem. Hey, if this is 55, then the central angle, you may say that, sir, where is that chord? Chord is here. Chord, arc, doesn't matter which way you look at it. Some people say that angle inscribed by the arc. Some people look at this, hey, which is the arc? AC is the arc. What is the angle inscribed by the arc? 55. Therefore what is the central angle, or what is the central angle made by the arc? Double of this, which is 110. Some people have the habit of looking at this as the chord as well. Take it as the chord. AC as a chord inscribes an angle 55, therefore AC as a chord, central angle made by AC chord becomes 110. Okay, very simple. My point of this particular question is quickly to remind you about the inscribed angle versus central angle. We all know that relationship, but the point is, before you find the inscribed angle, this particular construction was essential. This construction was essential. Good. Okay, now coming to this, a lot of people kind of do this. This is very standard question. The very first question that I picked is also a standard question. This is a very standard diagram. If you see this kind of diagram, symmetry, no symmetry, doesn't matter. If this piece angle is given to me, if this piece angle given to me, here it is going to be 2 times of 24 plus 31. It's a standard diagram. No sir, I can't remember so many things. Don't worry, do this construction and do that part. No, if you can remember, because we just have about 30 days to the exam. If you can remember, go on to remember, because it's a pretty standard diagram in geometry. So what I'm trying to say, hey, if this particular angle is x, if this particular angle is y, this angle is going to be x plus y, and this angle is going to be 2 times of x plus y. That's a relationship that you learn in the high school, which is one of the very standard diagrams. Okay, nevertheless, I was talking about inscribed versus central angle. Okay, all comfortable friends? All good? 1 point revision, where I was technically talking about the inscribed angle versus central angle with this question. I will not do too many questions based on that. Yeah, this is the point on the top of our mind. That's it. Yeah. Okay, nice. Fair enough. Let's go to the next one. Let's go to the next one. Here we go. Hey, all these are cat replica questions. I change numbers. That's it. I change some numbers here and there to suit our learning, and I remove answer options, because all these questions can come with boxes as well, right? Good. All right, here we go. Simple one. 1 minute. Some of these questions are 1 minute questions. These are warm-up questions. 1 minute. Yeah. Very good. I was talking about the tangent here. Very nice, very nice, very nice, right? Yeah, very nice. So what I was talking here, I was talking about the tangent. If there are two circles, this is called as transverse common tangent, right? This is nothing but, what is this? This is you may say that, sir, why circles should be, need not be. So this can also be fine. This is called as the transverse common tangent. Okay, let me say classical way of explaining this. If there is a line, if there is a circle here, and if there is a circle here, now this particular tangent is called as the transverse common tangent. It's a common tangent because this line is common to both the circles. Therefore, but then one circle lies on one side of the line, the other circle lies on the other side of the line. We also call this as a transverse common tangent. On the other hand, if I draw both the circles on the same side of the line, then I call this as the what kind of common tangent? One of them is the transverse, the other one is, what is the other one? What is the other one called? Quick. Anyone remember the names of two types of common tangent? Direct common tangent. Very good. Yeah. So this is a direct common tangent. If both are on the same side, direct common tangent. There are some formulas for this. Yeah, all that later point. So now coming back to this. Also, the third point here, from an external point, two tangents can be drawn to the circle. From an external point, exactly two tangents can be drawn to the circle. Say P is an external point. You are drawing two tangents. That's PA is a tangent. Say PB is a tangent. And they measure equal. Yeah. Direct common tangent, transverse common tangent. From an external point, two tangents can be drawn drawn and they are going to measure equal. Sure, you might have studied little more about the tangents. As we go along, let's try and explore what all things come with the tangent. For the time being, this is good enough. From an external point, two tangents can be drawn and they measure equal. So now therefore, hey, this length should be same as this particular length. Forget this story. Forget this side of the story. Just look at the bigger circle. Let's look at the bigger circle whose center is C1. Hey, this is an external point. What is an external point? C is an external point. From an external point, two tangents can be drawn and they measure equal. Author says that, man, this is 7. Then I know that this is also 7. Okay, all right. Then forget this side of the story. Remove this side of the story. Now consider this circle whose center is C2. From an external point called C, two tangents can be drawn. This is one tangent, that's other tangent, and they measure equal. Since this is given to me as 7, this also would become 7. Therefore, 7 plus 7 would become 14, right? You say that, what is the required measurement? 7 plus 7, which is 14. So I was just revising only one point on this question. From an external point, two tangents can be drawn and they measure equal. Fair enough. Are we good to go to the next one? Good to go to the next one. I will not remind all the properties of tangents. As we go along, we will learn. As we go along, we will learn through different questions. Wherever a little bit of background is required, I will start giving the background. How you would have, what is the concept behind this question? That background I will revise. Not all background on tangent at once. That's a pre-reads that you should have read. These are pre-reads, right? Okay, good. All right. So here we go on to the chords. Here we go on to the chords. Yeah, let's do on this. Yeah, this maybe I will give 2 minutes. A little bit of calculation is there. Yeah, go ahead. That is a beautiful cat question. I changed the numbers. Very beautiful cat question on chords. Yeah, okay. There are two things out here, right? One I was talking about chord, the other one was I'm extending the learning from the tangents. Listen, everybody listen here. Everybody listen. First, let me quickly remind you about it. Hey, what is tangent secant theorem, right? So what is tangent secant theorem? So let's say this is P, this is A, B. That is P to B is a secant. Then say this is C and D, tangent secant theorem. There are proofs, right? So I'm not getting into the proof side of it. I'm quickly reminding you what they are. Yeah, what is tangent secant theorem? This is the point, common point. So that you first look through this secant and you then look through this particular secant. All measurements from A. What do you mean by all measurements from A? From P to A you measure. That is PA, the distance, all right? PA length, and P to B. PA into PB. Proof comes from similarity. Just do a construction and similarity, you will get the proof. No big deal. So PA into PB is also equal to PC. All right, you say that PC into PD. right? This is called as tangent secant theorem, right? So this is called as a this is called as a tangent secant theorem. Why do they call it? We will come to it, because this is the original form. So there is one secant and there is going to be one tangent. It comes from there. Okay, so I have P here, I have A here, I have B here, and I have T. T is a tangent to the circle. From here you say that all measurements from P, from this particular point, PA into PB here, PA into PB is also equal to PT square, right? That's nothing but PT square. Fair enough. The third portion of this, hey, what if the point lies inside? I have a circle. Let's say that, hey, there is a chord inside here and there is another chord inside here. Okay, now this particular point is P. Let me call the other side as A here, and this is B here, and C here, and D here. AB is one line, CD is another line. Here also it is same. All measurements from free PA on the same line, PA into PB. It's the same theorem basically. PA into PB is also equal to, then you say that PC into PD onto the other line. Hey, all are same, all are same. My point is what? Hey, the point can be either an external point like here. The point can be an external point. Here I have an external point. Or that common point can be an internal point as well. It could be internal point. External or internal doesn't matter. It could be external point, or just like you see it here, it can be an internal point. External or internal, my tangent secant theorem remains constant. Good. So how do I apply this? Now this is what I will apply on this first. Well, this is what gets applied first. In the sense, when I looked at this particular question, the first thing is, hey, I should kind of recall the tangent secant theorem to start with, right? That could be the easier approach on this. How do I get this? There is a common point E here. There is a common point E here. Therefore, when I apply this, I understand that a PC, okay, P into E into C, all points from E, EC into ED, EC into ED is also equal to EA into EB, EA into EB. Okay, I do this and get what? Let's understand this. There is a roadmap, which means you kind of already seeing, visualizing certain things. The chord theorems, etc. are coming into your picture, but this is where you kind of start with. Okay, do I know the measurement of EC? Yeah, 77. Plug this. Hey, do I know the measurement of EC and ED? Right, EC. Do I know the measurement of ED? Yeah, 27. Plug this. Hey, do I know the measurement of EA? Yes, already EA I know, 99. Plug this. Therefore, I will get the value of EB from here. Okay, 11 9 times, 11 7 times, 9 3 times, and hence you say that EB is nothing but 21. The measurement of EB is 21. That's the first part. In the sense, you are now trying to say that, hey, I know this is 21, so EB is 21, the other side is 99, and this particular leg is 77 and 27. Guys, first, everybody clear about the tangent secant theorem? This is clear? Everybody clear on this? What I explained through those three diagrams, that is recalled? That is recalled, and one portion of tangent secant theorem is what I applied on this. Comfortable? Comfortable? That's the first leg of our operation. That's the first leg on this particular question. It doesn't take much time. You know the theorem, you will apply. You know the theorem and you will apply. That's it. Okay, just that already these things should be on the top of our mind. As simple as that. All right. Okay, now having understood the first portion, now the first portion is done. So now let me come to the second piece of operation. What is the second piece of operation? Built on what? If I have a chord, all right, if I have any chord anywhere, if I have any chord, if I join this chord to the center, if I drop a perpendicular from the center of the circle to the chord, if I drop a perpendicular, listen to this, I deliberately dropping, I have a chord any which way, right? Now that chord should be all right. Now anyway, let's say that, hey, this is my chord AB. I'm just drawing nicely so that you kind of feel it better. So AB is a chord. I have a chord AB here. Now I have a center of the circle O. I drop a perpendicular to this particular chord. If I drop a perpendicular to this particular chord, it bisects the chord. This is called as chord bisector theorem. This is called as the chord bisector theorem, right? Yeah. Other way around is also fine. Sir, I pick the midpoint of this. I pick the midpoint of this and draw a perpendicular. Yeah, then it will go through the center. If you drop a midpoint of the chord, you take a chord and you draw the midpoint, you mark the midpoint of it and drop a 90-degree line. That line goes through center. So that's what I mean by the chord bisector theorem, and little more many other properties. We'll come to it as we progress. But this is one of the important properties. We also call this as the chord bisector theorem. Two theorems we talked about. Tangent secant theorem. First we applied that. Then we are now talking about the chord bisector theorem. Let's understand why chord bisector theorem. We'll come to it. Okay, I will drop a midpoint on this. I will drop a midpoint. All right, now say this is the center, O is the center. I dropped a perpendicular to the chord CD. Then I get the midpoint. Then naturally this becomes the point M, which becomes midpoint. If I want to understand what is CM, good. CM is equal to CD divided by 2. CM, all right, because M is the midpoint. CM is nothing but CD divided by 2. What is CD, man? CD is 77 plus 27 divided by 2. That is 104 divided by 2, which results in 52. You are now trying to say that CM is 52, but this was 7 already this was 77. From here till here it was 77. Out of 77, 52 is on this side. Therefore, how much is on this particular side? Remaining 25 is on this particular side. In the sense, I broke this length. Hey, this piece is 52, another piece 25, another piece 27. Total 104. I broke it into 3 pieces. Good. Can I do the same thing on the other side? Of course you can do. You may say that, hey, I will drop a perpendicular on this particular side. Let me call it as N. Then what is the measure of AN? AN is equal to AB divided by 2. What is AB? AB is 99 plus 21 divided by 2. That is 120 divided by 2, which results in 60. Good. You are now trying to say that, man, this is 60. If you want the measure of this, out of 99, 60 is on this side. Therefore, rest of the portion would be on the other side. You would say that remaining 39 would be on this particular side. Fair enough. All this part. Yeah, how many parts are required? Different issue. What I proved you here, how do we look at the chord bisector theorem, the importance of chord bisector theorem. Good enough. Now coming to this. Now draw a radius wherever you feel like, hey, I will look at this as the radius. What if I take this one as the radius? Is this the radius? Yeah, because this is the center. O is the center. This is the radius. Now can I get the value of the radius? Surely. This base is 60. Focus only on this triangle. What about this? This is 25. Shift this 25 here. Both are the same lengths, therefore 25. Now you are saying that, hey, I have a right angle triangle in which one dimension is 60, other dimension is 65. Therefore the third one is 65. 25, 60, 65. You may wonder, how do you know this? I talked about the triplets. This is the function of 5, 12, 13 triplet, right? 5, 12, 13. Take the HCF of these two numbers. You understand that the HCF of these two numbers is 5. So therefore we actually technically multiplied this by 5, and hence 5 into 5. 25. This was 60. Therefore, in my mind, I understand that 13 into 5, which becomes 65, which is the radius of this particular circle. So, what if it was not a triplet? And then we will find out under root of something square plus something square. That's what we kind of do. Okay, 2 theorems are clear. We technically looked at revising 2 theorems through this question. All good? All good? Yeah, tangent secant theorem and chord bisector theorem. All good? Yep. Yeah, these are all popular theorems. What we are talking in the beginning is most popular things. These are all most popular things we are talking about. That's right, Nazia. That's right. Yeah. Very good. Awesome. Yeah, here comes the next one. So we are ready for the next one. Here comes the next one. Yeah, try and recall what concept to go with this now. What is that we are kind of talking here? So I will give about a minute's time because this should not take much time. Look for the underlying concept. All right. Listen, guys. Everybody listen. Yeah, listen. Everybody listen. Alternate segment theorem. I was actually talking about alternate segment theorem. Listen, everybody listen. What is alternate segment theorem? If I have a tangent, what is the requirement? I have a tangent from the point of tangency. Let's say this is T, this is P, this is Q. From the point of tangency, I have a chord. I have a chord. It need not go through center. I have a chord. All right. I have a chord. Let me call this chord as AT. From the point of tangency, I have a chord. What is alternate segment theorem? If this particular angle is alpha or theta, whatever you want to take. What is theta? Theta is ATB, ATQ. Angle ATQ is equal to theta. Then do any construction on the alternate. Look at the word alternate segment theorem. Segment. Right. Look for the alternate segment, because now this angle is a part of this particular segment. Where is this angle? This angle is getting into this particular segment, alternate segment. I am saying that, hey, draw anything in the alternate segment that also would be equal to theta. This angle also would be equal to theta. We call it as an alternate segment theorem. You may say that, sir, what if I give another inclination here? I will draw like this. I will give an inclination like this. Yeah, that also will be theta. These are all inscribed angle. All at 80 is the chord. 80 is the chord on this particular chord. They are all theta's. They are all theta's. Angle. Therefore, I am talking about only one theorem I was questioning in this question. Alternate segment theorem is what we were talking about. Good. So let's see that. Where is that alternate segment theorem applicable? Here, this is 35. Okay, then angle PCA, this is 45. All right, so I can look at this particular triangle. I can first find out this particular angle. To start with, I can find this particular angle here. Yeah, I have 35 here, I have 40 here, and therefore that is 80. Therefore, this is 100. Good. If this is 100, where do I apply alternate segment theorem? Listen to this, guys. Listen to this. Hey, this is the chord I am taking as the reference. Listen carefully. This is the chord I am taking as the reference. Here is my angle 45. 45. This is my tangent. This line is my tangent. If this is 45, then this is also going to be 45. If this is 45, then this particular angle. Now look at this exterior angle. Take a look at this particular triangle. What is this 100 here? Exterior angle. Exterior angle is sum of the interior opposite angles. If this is 45, then this is going to be 55. Now this 55 is an inscribed angle because this is the tangent. This is the chord I am talking about. This chord inscribes an angle of 55 degrees here. Therefore, the same chord inscribes an angle of 110 degrees here. Guys, did you understand where we applied alternate segment theorem? Here, all it here. This is where I applied the this 45 I am circling is this 45 resembles this 45, courtesy alternate segment theorem. Clear? Everybody clear? Courtesy alternate segment theorem. Clear, everyone? Clear there? Yes, no? Yeah. Clear? Yeah, PC is tangent. That's right, Srishti. PC is tangent. PC is tangent. That's right. Yeah. How 100 it should be 80? What is 80? No, Shivali. Interior angles are 180, right? Why you are getting these kind of doubts? Is this the 11 o'clock effect? Are you guys tired already? Getting closer to this? Why? All right. So you are saying, got it? Rectified. This is 35. This is given to me 35, and this is given to me 45. This should be 100, no? Sum of the interior angle should be 180, right? Why 90 or 80? Because this is 35 and this is 100 to start with. Yeah. Why it makes 90-degree angle with the center? 90-degree angle it makes, tangent makes, which means from the tangent, only if you drop the line to the center, only then it will be 90-degree. Otherwise, why it should be 90-degree? If you take any chord, if you take only the longest chord passing through the center, it makes 90-degree. What if from the tangent I will draw this line, Srishti? Why this should be 90-degree? There is a tangent line coming from here. Why it should be 90? 90 I can take provided I am guaranteed that that chord is going through the center. What if that chord is not going through the center? Yeah. It connects or not, that also I don't know. Such clarifications may not be required. Right. So I will not take it for granted unless it has been said or unless that can be proved. Everyone clear on this? Making sense? Some of you are saying that how C is 55, exterior angle is sum of the interior opposite angles, or do whichever way you want, guys. Let me show this. Okay, firstly, I got this as 45. I got this as 45, so I think you guys are tired today, right? Yeah, and now you will make me tired asking these many questions. Nevertheless, I will explain patiently, that's not a worry. So this 45 becomes 45. Okay, this is 45. All right, Srishti, this is 45, courtesy alternate segment theorem, because this is my chord. This is my chord, courtesy, that is 45. All right, now take a look at this triangle CBA. I will highlight this. Okay, here is my C, this is my B, and this is my A, and this is 45. And I know this particular angle is 100. I knew that, okay, this becomes 100. Now 100 is an exterior angle. Exterior angle is sum of the interior opposite angles. This 100 should be 45 plus something more. All right, what is that something more? 55. You may say that, no sir, I will approach in a different way. Approach it. If this is 100, you may say that this is going to be 80. Good. If this is going to be 80, come back and write this as 55. Either ways, I am fine. Which way you approach it is fine. You still get that as 55. Comfortable? All clear there? Triangle property I am talking. Yeah. Yeah. All got it? Give at least loud confirmation that this is clear now. I took so much time to explain. I think almost I explained 3 times now. More or less. In bits and pieces. Now at least give a confirmation that it is very clear. Yeah, your doubts are fine, but at least give a confirmation that satisfies me. Yeah, good. All right, so here we go, the next one. Yeah, great. Thanks for your confirmation. Go ahead, friends, try this. Try this again. 1 minute. 1 minute. One property I'm talking, not much. Not much. Not much. Go ahead. Yeah, okay, what happened? So construction, don't forget construction, right? Construction. How do I capitalize this angle 65? Listen to me. There is no one standard rule. So whenever you get stuck, understand that I may have to draw some lines. How do I capitalize on this? I already put the trigger in place. That's why I reduced the time. So otherwise 2 minutes would have been a good question on this. I will drop this construction. I will draw this line. I will draw this line. Let me call this point as C. I will draw this construction line. The moment I draw this construction line, courtesy alternate segment theorem, I get this as 65. I get this as 65. Courtesy alternate segment theorem. Here is my chord. All right, here is my chord and here is my tangent. All right, now because what is the alternate segment theorem? What are the triggers for alternate segment theorem? A chord and a tangent. All right, at the same point. A chord and a tangent. All right, at the same point. Fine, I have it at A, the chord and the tangent are meeting, and that is what is making 65 there. So if that is making 65 alternate segment, so naturally you may say that, sir, I will draw something like this and call this also 65. Don't complicate it. Whenever you are doing constructions, we said that use the existing points, things like that. Okay, I will use these 2 points and I will close this. And I call this, okay man, this is also 65. Good. And angle in the semicircle, what is the next point? Hey, angle in the semicircle is 90 degrees. Once you do this, that automatically triggers it. Angle in the semicircle is 90 degrees. You may that is 90. You may say that, hey, what if I draw something like this? It doesn't matter. They're also 90. Therefore, you understand that this is automatically 90. This angle becomes automatically 90. Why? It's angle in the semicircle, right? Angle in the semicircle for the triangle ABC. ABC is nothing but the triangle which is a where BC is the longest chord diameter. So therefore you understand that that is 90 degrees. Oh, very good. Triggers, auto trigger. The moment you put this particular line, you get 65 and you get 90. Good. All right, you get these 2 angles, and then you automatically find this particular angle which becomes 25 degrees. which is 25 degrees. Oh, you have enough information to find the angle P here. One way of looking at this particular question could be this. Once you get this, hey, remove this in your mind. In your mind, you are kind of removing. You are saying that exterior angle is sum of the interior opposite angles. I have 25 here, therefore I will have rest of it featuring here, which is nothing but 40. You may say that, no sir, I will approach differently. Sure, after having so many angles, approach whichever way you want to approach, you get this 40. But the point is what? Hey, one, construction. Don't forget the construction. Whenever you get stuck, think that, hey, should I draw one line out here? Alright, that's one thought that you have to have. Construction, do a meaningful construction that would have led to angle alternate segment theorem. Then you understand that a angle in the semicircle, angle in the semicircle is 90 degrees. Alright, you apply these two parts, you are getting the answer from there. Comfortable? All good here? All good? You reached 40? Everybody reached 40? Along with me, along with me or not along with me, doesn't matter. But did we all reach 40 there? What is the answer? Did we reach? Yeah? Good. Yeah. So properties, focus on the properties, and I told you in the previous lecture already that construction lines, don't forget. If the figure is given, ensure that, hey, there might be a construction. There might not be, but always the thought should be there might be a construction. Keep that in mind. Okay. So here we go to the next one. Yeah, here comes the next one. Tackle this, friends. Everybody tackle this. I will give good 2 minutes now. Good 2 minutes. Relax and tackle it. You don't have to race. Relax. No need to race. Relax a little bit, but tackle this question. Yeah, most of the basics are revised by now. Most of it. Most important, vital ones are revised. Some things are here and there left. That's all right. Majority is revised. Yeah, you can expect, Rishabh. You can expect this level. Can we expect? Why not? You can expect, right? You can expect this. You can expect harder than this also. You can expect. In fact, these are CAT questions only, what we are doing. I only just change the angles. That's it. In fact, all the questions that we did are the CAT questions only. Some of them easy. Some of them have multiple properties. Some of them have single properties. And the harder than these questions also are there, which we will see in the future lectures, right? Which we need a lot of patience as well. All right, because we are now talking only just with respect to circles. So we can bring some dimensions, this, that, all of it, right? So then that makes it much more complicated. Yeah. Yes. Yeah, but then, yeah, this is the kind of reasoning we can expect. This is the median, right? This is the median. So there will be ups and downs from here. Okay, great. So let's take a look at this. Say, what is this? This is 90 degree. Forget this particular line for the time being. Leave this line and don't consider this particular line. So what is this? 90. Yeah, what is this? 90. Look at the quadrilateral. I'm talking, say, look at this quadrilateral. O, T, A, Q. O is the center. It is given that center is O. All right. Now, therefore, I said that, hey, this is a tangent. All right. There is a tangent. Tangent and the radius. All right. There is a tangent and this is the radius drawn towards the center. So, therefore, that is 90 degree, 90 degree. And this is given to me as TAQ is given to me as 50 degree. Angles of a quadrilateral to be 360. Out of 360, I have a 90 here. I have a 90 here, and I have a 50 here. Naturally, I know that, hey, this is going to be the remaining 130 because I have 90, 90, 50. Therefore, the remaining is 130 because angles of a quadrilateral are 360. That is the first stage that you reach. Okay, that's the first stage that you reach. You reach quickly that, okay, this angle becomes 130. That's a no-brainer. Till here you reach it faster, right? That becomes a faster. So from here, if you just make a construction, life becomes sorted, much more sorted. Assume that, hey, I made this construction. All right, there is a central angle. If there is a central angle, what is that I'm talking? I'm taking the chord TQ. On the chord TQ, the central angle formed is 130. Therefore, inscribed angle becomes 65. What is the 65? Inscribed angle. Which tangent, which chord I'm thinking here? TQ. Of TQ forms a central angle of 130. Therefore, inscribed angle becomes 65. Good. Okay, now I have this 65. Now focus only on this. Let me call this particular point as S. Let me call this as S. Look at T, Q, S, P. This is called a cyclic quadrilateral. This is called a cyclic quadrilateral. Don't look beyond the pink lines. Look only the pink lines. Right? The pink lines forms the cyclic quadrilateral. We know that in a cyclic quadrilateral, the opposite angles are supplementary. If there is 116 here it is going to be 115. 65 on one side, 115 on the other side. Because it's a cyclic quadrilateral, opposite angles are supplementary. Okay, did it make sense? 115 as the answer. Clear to you? Everybody clear? We have two quadrilaterals basically. That's it. There is a circle. We had one quadrilateral to start with. Then we have, after a construction, we have cyclic quadrilateral in between. That's it. We have two quadrilaterals. This question was just about two quadrilaterals kind of formed through the circle. So where we are talking about inscribed angle and central angle. Alright, which we are all very familiar with. Clear? Okay. Alright. Alright, okay, crack the next one. Everybody crack the next one. Beautiful question. Beautiful cat question. I just changed some angles and sides. Same, ditto, cat question. Try this. Everybody try this. A minute is a good time, but I am not in a hurry. I will give 2 minutes. Calm down and relax and try this. All concepts are dealt. All major concepts are dealt. All you got to do is apply. Think. 4 or 5 things will come in your mind. Keep applying them. What works? See. That's the meaning of giving about 2 minutes. Diagram is a trigger. Data is a trigger. It triggers 4 or 5 thoughts in your mind. Quickly keep applying them and check what works. Yeah, very good, guys. Yeah, very good. That's brilliant. Brilliant response. Very nice. Very nice. Okay, so let me just tilt this diagram a little bit. I just brought this point C here, and I have A and B on the other legs. I just tilted this particular diagram just for our better understanding. What is given to me? This measurement is 12, and what else is given to me? This particular angle here. All right, angle between them. This is 135. Now it forms a cyclic quadrilateral. If you just follow only these pink lines. You just follow these pink lines. The pink lines form a cyclic quadrilateral. Cyclic quadrilateral. Simply extend that. This is a construction line. Simply extend that. That forms a cyclic quadrilateral. If therefore in a cyclic quadrilateral, if this is 135, supplementary angle, this would be 45. This would be 45. Cyclic quadrilateral. Just extend that. So learn to extend that. See, therefore constructions are important. What is the point I'm trying to draw? Whenever the figures are given, never take this word construction out of your mind and do a meaningful construction technically, right? Okay, so 135 and therefore this becomes 45 because these two angles are supplementary. Good. So once you got that as supplementary, then you say that, hey, there is a chord here. The chord inscribes an angle of 45 degree here, which is the chord I'm talking about, AB as the chord. The same chord, therefore subtend central angle it forms is 90 degree. Good. So 90 degree here, and I know that, hey, if this is 90, alright, this particular angle is 90 and these two sides are equal. This is radius, right? This is radius and this is radius. What is that? Just focus only on this triangle. Focus on triangle OAB. There is O here, there is B here and there is A here. Focus only on the two sides are equal. Therefore the angle opposite those two sides would be equal. And hence I have a 45 45 90 triangle. We were talking about this yesterday. In a 45 45 90 triangle, the sides are in the ratio 1:1:√2. Alright, root 2 corresponds to 12. Therefore 1 corresponds to how much? That is the value of the radius, right? Therefore you say that 12 divided by root 2. What is 12 divided by root 2? As most of you said, it is 6√2. Comfortable, right? So it's a very simple question. Absolutely very simple question. All you could have done is what? Just do that construction, meaningful construction to figure out, hey, there is a cyclic quadrilateral that can be formed. A circle and the lines, just understand that whenever you are doing construction, most popular constructions are going to be cyclic quadrilaterals. These are the most popular constructions that are going to be out here, right? Yeah, so that you got to kind of keep it in mind, because in a circle, when some lines come in here, if one angle is known, cyclic quadrilateral is the most popular construction that we do. Just keep this point in the constructions, keep this point cyclic quadrilateral in your mind, keep it out there. Yeah, all right, so there we go. Are we good to go to the next one? Guys, are you all learning something? Good revision happening? A good revision happening? So all your concepts of circles are coming into the surface. Yes, no? Yeah. Yeah. Yes, Keval, that's right. Because it's only on circles what we are doing. We are not squeezing too many things out here. Right? Yeah. But that's important. You got to visualize these things. These are pretty basics. All right. So here comes the next one. Because we are not talking beyond one property. Think about it. Rarely we are talking two properties. Otherwise, it's one property. One property should not be a challenge. Yeah, thanks, Ashutosh. All right, go ahead. Of course, CAT questions are a little deceptive. A little deceptive. Even with one property, they are deceptive. Yeah, let me give a minute. I didn't put the timer, right? Now I also don't know how much time I gave. Nevertheless, no worries. Just take a minute from here. Guys, it should be more than 70. Okay, Rohan, Ratishri, look at the size itself. If this itself is 70, don't you think that this should be more than 70? Doesn't it look like that? And there is nothing wrong in the looks, right? There is nothing wrong in the looks, right? Yeah, you have to give an answer more than 70. Don't, at least, even with the choices, your guess should be more than 70. All right, let's take a look at this. This is one of the beautiful questions, right? This is one of the really beautiful questions. Let's take a look at this. Let's take a look at this. Let me redraw like this. This is the construction. Now look at the two lines that I have drawn. That's a construction there, okay? Hey, what is that construction? Let's try and understand. Listen, all of you listen very, very carefully, my friends. If you want, you can come. Okay, what is given to me? Only this. This is 70 and I need to find this. All right, let's keep that in mind. And if I were to complete this, this is the circle, right? This is the circle. If I just were to complete this, this is how the circle looks like. Now everybody listen to me. This is the center of the circle. This is the center of the circle. If at the center of the circle, the angle formed by this chord, it is upside down. That is what CAD does, right? So we are used to look like this. Hey, there is a chord here. The chord makes an angle of 70 at the center. Then we say that the inscribed angle would be 35. But the same figure, author is saying that why don't you look upside down, right? It's deceptive. Why don't you look this particular figure upside down? Fine, man. I looked it upside down. Therefore, if this is 70, now look at this same chord. Which chord I am talking about? CD. CD forms a central angle of 70. CD is already making a central of 70. Listen, everybody listen. If I drop this here, this is 35. This is 35. Okay, now let me say, let me say, I will make this green line. Let me drop it here. This is also 35. Why? The same one, CD only I'm talking about. The same CD, if I drop it here, let me call this particular point as X and let it call it as Y. Then I've came to the point called A. A is also on the circumference of the circle and hence this angle is also 35. Now, give me a quick confirmation that yes, we understood this is 35. Clear there? Angle formed by CD at A is 35 because this is the inscribed angle. 70 is the central angle, 35 is the inscribed angle. That is clear. That is clear, everybody. That's clear. CD, alright, chord CD forms a central angle of 70. At A, it forms an inscribed angle of 35. 35 is an inscribed angle formed by chord CD at A. Hello, are you all with me? Quickly confirm, as many as of you could. CD puts a central angle of 70 was given. Therefore, I am concluding that, therefore, the inscribed angle, because A is on the circumference of the circle, point A is on the circumference of the circle, right there. Therefore, it forms an angle of 35 degrees there. Yeah, that was the first cracking point. That was the first cracking point. All right, now the problem is over. All right, with that the problem is over. You may wonder where it is over, sir. Okay, let me see this. Now focus on this particular triangle. I am circling this. Focus on the triangle D. Focus on this particular triangle D, A and B. In a triangle DAB, angle D is 90 degrees. Why? Because it is angle in the semicircle. That is angle in the semicircle. That's all it is, the longest chord. All it, this longest chord, all it inscribes an angle of 90 degree out there. That inscribes an angle of 90 degree. Okay, so that part is done. So once that particular part is done, focus on this particular triangle. Which triangle? I am saying that focus on the triangle ADE, or by now you know that E is an exterior angle for this particular triangle ADE. It looks like this, my friends. It's looking something like this. Hey, here is D here, there is a here, and there is a point E here, and it is going out up to C. Okay, I know that this is 90 degrees and I know that this is 35 degrees. Therefore, this is an exterior angle which is sum of the interior angles, which is 90 plus 35, which is nothing but 125 degrees. Beautiful question, very beautiful question. Once first you need to understand that there was a question of inscribed angle. Construction was required. First thing is the right construction. Therefore, I gave 2.5 minutes. Point is what? You draw some lines here and there to check. You don't know. Hey, same construction you could have done this side also, right? There is no hard and fast rule. You got to do this construction and this construction. Why? Because you understand that, man, what is given is a central angle. That's a trigger point. If the central angle is given, let me find the inscribed angle. Whenever central angle is given, look for inscribed angle. This is the second time this kind of question is coming. In another question also we did. Whenever the central angle is given, look for inscribed angle. Whenever the inscribed angle is given, look for the central angle. These are the auto triggers. triggers. These are the auto triggers. Is it useful? That I don't know. But if the central angle is given, I will automatically think of inscribed angle. If inscribed angle is given, I will simply think of central angle. Will it help or not? I don't know. It might help, it might not help. But more often than not, it at least helps in one or the other way, because I'm at least finding some angles out there. Okay, that's the point there. So you get this 70 as the central angle because it's given, it is at the center. It is at the center O. Therefore, you fix this chord to start with. Then you realize that I can either form an inscribed angle of 35 this side or this particular side. Which side you form doesn't matter. That forms a trigger. Then you know that, hey man, there is a longest chord here and there are so many lines going there. There must be a 90 degree which this longest chord is forming. You may say that either this is 90 or this is 90. It doesn't matter which side you make it 90. You find a 90 there for sure. And then once you have a couple of angles in your basket, you can find many other angles. It is just to start with, I need to have little more angles because all that was given me was one angle. Once, just like a Sudoku, some numbers are there, you plug some more numbers, the rest all numbers can be formed. That's all the game here is. Okay, making sense? Making sense, everybody? Did it make sense? Very deceptive picture, because looking from the top like this is little dangerous. I mean, that does not occur so easily, but the central angle was the key. Yeah, making sense, everybody? Okay. Right, very good, very good, very good. All right, here comes another one. Another one, beautiful cat question. Think about it. We are not still talking too many triangles, this, that. We are not making any cumbersome thing here. Just one or two properties, especially on circles, one or two properties. And then, of course, angles of triangles, etc., which we are pretty familiar after 4 lectures on triangles. We did 4 lectures on triangles, to my surprise. This is the 5th lecture on geometry on circles. Of course, first lecture on circles. Yeah, go ahead. I think I will still give them 2 minutes. I'll wait for 2 minutes. Apply them. Lot of thoughts will come. This triggers the thoughts. Do some constructions here, there, all that. Yeah, all right guys, let's do this. I give sufficient reflection time, just a matter of time. You guys might have done already a lot of construction. You'll be about to get, no worries, just listen to me, just listen to me. Hey, what is given? Central angle, this is 110. Central angle is given. What is given? Another central angle. Technically, central angle is given. Therefore, my mind says what? If there is a central angle, fellow, figure out where is inscribed angle. Where is inscribed angle? Will it help? That I don't know. But at least this is the first thought. The moment you say that central angle is given, so all I got to do is I got to find the inscribed angle. Okay, that is the first thought the mind says. If the central angle is given, I got to find the inscribed angle on this. Okay, there is one part is missing. O is the center. Wherever you find O, at least if I miss it, because while copying the questions. If I miss it, just figure it out that as the O is the center of the circle. Fair enough. Okay, central angle given. First thought is figure out where is your inscribed angle. To find out inscribed angle, two constructions you may have to do. Either do this construction, you get the inscribed angle. You may wonder from where, sir. Say there is 100 here, this is 110. Which chord I am talking about? I am talking about the chord BD to start with. Let's say this BD makes an angle. This becomes an inscribed angle which is called as 55. Otherwise, another way also, there is no one hard and fast rule. That's a point I am trying to say. Don't think that there is only one way to proceed. No, not like that. Okay, what if I make this particular construction? I am fine with that as well. What if I do this construction? I would still take this particular chord. This particular chord forms a central angle of 110 degrees here, and hence this becomes 55. There are two openings. Similarly, you can think of the other side as well, right? Other side as well. Okay, here we go. Let me quickly explain this question to you. I have taken one of the construction lines. Good. Therefore, this is 110, which is given to me, and hence this forms 55. This whole thing forms 55 degrees. Now look from the same perspective. Listen to me, guys. Very carefully look at this. Hey, this is solid now. So here, hey, what was the chord that I have taken here? Here, I took BD as the chord. BT subtends an angle of 110 degrees out there, and hence it subtends an angle of 55 degrees at the circumference. C is at the circumference. That is an inscribed angle. Good. Now with the same construction line, dotted construction line, I will shift my chord here. I will say that this one, hey, this is forming a central angle of 40 degrees, which author has said this forms a central angle. Therefore, the same chord at the vertex of at this particular circumference, the same chord forms an angle of 20 degrees. Okay, guys, the 20s and 55s are clear. This 20 and this 55 are clear. Quickly confirm, because that's a beginning point. A construction line was required. Because to get from central angle to inscribed angle, some construction line was required, without which you cannot convert a central angle to inscribed angle. Clear there? Clear there? Clear? Ashutosh, not clear. Forget this. All right, now look here. Look only this diagram, man. Look only this diagram. See, you need to have that beauty to see them. You need to have that beauty to see them. Look at this particular chord AC. Look at this particular chord AC. AC makes an angle of 40 degrees at the center. It is making and subtends an angle of 40 degrees at the center. Then AC will subtend an angle of 20 degrees. Let me call this point as X. Okay. Now let me say that AC also extends an angle of 20 degree at Y. Then AC will extend an angle of 20 degree at B also. If it is extending an angle of 20 degree at X, 20 degree at Y, why not at B? At B also it extends an angle of 20 degrees. Clear? Clear? You should be able to see that. You should be able to see that. The diagram is looking dirty. That's how the author wanted. That's how the author wanted. Same thing. All right, now this is the same diagram which is extending an angle of 20 degrees at the circumference. Clear there? Yeah. All right. So that is 20 there. Okay, that is 20. The problem is over with that particular 20. It is done. Okay, so what is done? So we know that this is 55. This is 55. All right, this angle was 55 because this was given to me as 110. Now look at this particular triangle. Which triangle? Just look at this particular triangle here at this point. Just look here. There is a point P here, there is a point B here, and there is a point C here. In many ways, once you have these angles, please go ahead and find out in many ways. You understand that there is an external angle at C, all right, which is tending towards D. This is 55. 55 is an external angle. What is this angle? This is 20. If this is 20, external angle is sum of the interior opposite angles, and hence how much out of 55, 20 is here, and hence there is a remaining 35, which is the answer to this particular question. Comfortable? All of you understood this? Central angle is an automatic trigger for the inscribed angle. We did 3 questions like this. Central was given, inscribed has to be figured out. It's an auto trigger. It is an auto trigger. Guys, making sense? Everybody? Yeah. Good. All right. It is almost pretty much the time. Are you all learning something? Did you all learn something? Good revision. These are reinforcement lectures. I am not teaching basics. I am just throwing the thoughts and then trying to revise through the questions, all the concepts. What are the triggers you got to set up in your mind? That's what I was talking. Right? Good. Okay. All right. Probably all right. I might have to stop here. All right. Before that, quickly, couple of things. Sunday. What you should do on Sunday? Somebody type it in the chat, guys. Tomorrow is Sunday. Tomorrow is Sunday. Yeah, holiday. That we know. But what you should do on Sunday? What is that I expect you to do on Sunday? If you are following me. Otherwise, from Monday onwards, don't follow the lecture. Stop following. What you should do? Mock. Wonderful, right? Come Sunday, you got to write mock. All right, so that's for yourself, but I expect this, whatever the mock. All right, so on Sundays, write the mock and technically try and take the mock in the designated time slot. You all received your hall tickets for CAT, and if you are pretty serious about the CAT, please write it in the designated time as much as possible. As much as possible, try and see if you get those kind of slots, because like you might have to book your slot sometimes, all that stuff. Okay, yeah, try and take the slots at that particular point in time as much as possible. Not possible, don't worry, but at least try and see, because 4 Sundays try to write in the designated slot. I think 3 Sundays. The 4th Sunday you will be writing the CAT, right? 5th Sunday you will be writing the CAT. Okay, cool. All right, that's pretty much about what we want to do today. And a few announcements before we close it, guys. If you are getting any doubts, etc., please use this doubt platform. Ask a doubt. So because sometimes on the groups, if some things are not getting addressed, please go ahead and ask a doubt. Ask a doubt feature is there on your Unacademy app. If it is not reflecting, please update the app. Just update once. You find this right on your dashboard, and it is a self-explanatory. Please go ahead, cut it, paste it, and then figure it out. Then somebody will answer it as soon as they could. All right, so Sunday I will not be doing a class, as most of you know. Yeah, so those who have the afternoon slot, you can take this AIMT as well, All India mock test given by this free mock. You can try this as well. That is tomorrow. And if you are looking for the lecture, we will do the lecture on Monday. We will assemble back on Monday, and we will continue our journey with another lecture on geometry. This time we will squeeze in the triangles, circles, quadrilaterals, whatever possible we will try and squeeze in. So I expect you that, hey, read little bit about the quadrilaterals and come. I am not doing a separate lecture on quadrilateral. I will touch little bit of quadrilateral. Pre-reads for Monday. This is the pre-reads, right? Pre-reads for Monday is check little bit about the quadrilateral, the standard diagrams at least, right? Trapezium, parallelogram, okay, and then like so squares and then rectangles. So you are all at rhombus. Just little bit about that, touch base little bit as a pre-reads on the quadrilaterals. That will help us to zoom little further, faster into the lecture. Yeah, all right. That's pretty much about it. You guys have liked it, then don't hesitate. You can always press the like button before you leave. Yeah, and then subscribe to this Cat Ninjas, then you will get the notifications once we start. That's pretty much about this. All right, good night to all of you. So I will see you guys back on Monday. Best wishes to you. Do well in tomorrow's mock. Let it build some confidence as you go along into this. For the time being, good night. I will see you guys on Monday night. Bye till then. Stay blessed. God bless you. God bless you. God bless you.